Hello ladies and gentlemen, and just wanted to finish off what we were talking about on Friday. We went over quite a bit. Let's go over it again really quickly. I'll post these as PDFs as well so you can have them. This was our class discussion. I asked many of you just to sit and listen, and so you're going to want to make some jot notes or download this in the PDF form to have it for your notes. It's up to you. Anyway, we started with the class discussion and we went with trig functions. And there were the three primary trig functions. That was sine, cosine, tangent. And these are the ones that we remember from SOHCAHTOA. These came from the right angle triangles. We then talked about the fact that they are functions, so they have a domain and they have a range, and they take angles over to side length ratios. So the sine takes an angle to a side length ratio of opposite over hypotenuse. Cosine takes an angle over the side length ratio of adjacent over hypotenuse, and tangent takes an angle over to a side length ratio of opposite over adjacent. We figured out that they had ranges, so the theta could be any value in the element of the real numbers, which was new for us. That meant that we could have negative angles, and we could also have angles greater than 90. But it worked out for us. We saw that our ranges were between a minimum of -1 and a maximum of 1. Same for cosine. Tangent was different. Tangent had some asymptotes happening. They had asymptotes every 180 degrees after starting at 90 degrees. We came up with this as a short form of looking at this concept of rotational angles. So a rotational angle starts along the positive x-axis. We're going to call that the initial arm, the starting arm, and then that arm gets rotated. Okay, the arm gets rotated up from that initial position going this way, x is greater than 0. That initial arm keeps going up and up and up until it stops somewhere, and we call that the terminal arm. Okay, so this is the initial arm, that's the terminal arm. We decided that going this way was going to be positive. We decided that going this way was negative, and we decided that we could go all the way around and keep going, and that gave us those angles larger than 90 degrees, larger than 180 degrees, etc. It also gave us our negative angles. We looked at this a little bit longer and we said, okay, what if this had a radius of 1? If this has a radius of 1, then the total distance around the outside is 2 pi r. That's the circumference of any circle with a radius of 1 would be 2 pi times 1. So it's 2 pi would be a measure of length. It's a length measure around the circle. But we also have another means of measuring the length around the circle, and that's our standard degrees. So that was 90, that's 180, that's 270, that's 360, keep going, 450, 540, etc. So that meant that if we went all the way around a circle, we knew that that would be 360 degrees, and that's a measure around the circle. And 2 pi equals 360 degrees then. And from that we can do simple division. That means if I divide both sides by 2, pi is 180 degrees, pi by 2 is 90, pi by 4 is 45, pi by 3, and we learned how to count by these as well. We could do 1 pi by 2 plus 2 pi by 2, became, the 2's would reduce, became pi. 1 pi by 2 plus 2 pi by 2 plus 3 pi by 2 was 3 pi by 2, and we talked about converting back and forth. So that's a good thing to know as well. During our discussions, we also talked about the sine curve, and we drew it, and we had a nice little answer here, and we noticed that we had two answers for a particular range value. 0.5 had two answers, two domain answers. Still a function, don't get confused, it's still passing the vertical line test. Each domain function has only one range function. However, this range function has at least two domain functions if we only have one wavelength, and if we have multiple wavelengths, then it has an indefinite number of answers. You'll notice that the distance between here to here was 360 degrees. The distance between here and here was 360 degrees. The same is true going this way, but we were interested in the distance between them ultimately. So to do that, what we did was we talked a lot. We said there's an indefinite number solution. We said that our calculator would give us one solution, And we realize that our calculator only gives you the smallest solution between 0 and 180 degrees. In fact, it'll give you the smallest solution less than 90 degrees. But I wanted to keep it at 180 for right now, just for looking between here and 180 means that we're only going to have those two. Why are there two answers? Because sine starts at 0, goes up to 1, which means it passes the 0.5 mark that we want, and then it needs to fall back down to 0, which means it's got to pass that 0.5 mark again. So it's going to go by it on the way up, and it's going to go by it on the way down. So we went through that, and we wanted to know how to get the other answer, and I said we were going to use the cast rule. So from that, we took a look at the cast rule, and we said, okay, well, the cast rule is set up so that I can have related angles, similar angles in each quadrant. So this triangle, which is my first answer that I got with my calculator, 30 degrees, and that means I rotate from my initial arm up to my terminal arm, and I make a triangle. So that's my initial up to my terminal, and this is going to be 30 degrees. Well, if I reflect that, I have another triangle here that has 30 here as well. Okay, so what we did was, and we noticed that we could have other triangles down in this quadrant and down in this quadrant. The answer to the rotational angle to get 30 here, okay, so that's going to be 30, those are the same, is actually 150. Why? Because if I went all the way around to 180, and instead of making it to 180, I stopped 30 degrees before, it would be 180 minus 30, which is 150 for this part right here. And so what we say is that sine, what we're looking for is an answer to sine of 0.5, so we want to know where sine is going to be positive. Well, it's going to be positive in quadrant 1 and quadrant 2. We know that, looking back at our example, here's quadrant 1, here's quadrant 2, sine's going to be positive. Notice we will have a negative 0.5 in the other two quadrants, but that's negative, it's not the same answer, so we don't want this area because we know, following the cast rule again, C-A-S-T, that sine is going to be negative here and negative here. So that's not going to work out. And so what that does is it says that our other answer is in here, and we know that is going to be 150 by doing the work that we talked about, 180 minus 30. Okay, then we started on some of our actual sheets. So this sheet. Now, I called this the terminal arm because this said rotational angles are created when a terminal arm is rotated about an origin. The terminal arm is actually where it stops. I know I said terminal arm here. It actually starts at an initial arm, and then it's rotated around to give you the terminal arm. It's the same arm. The only difference is where does it start and where does it end. So it's starting here, initial, and the terminal arm is actually here. And again, it starts here on the initial arm. And the initial arm is always at the same place. It's always going this way, the positive x-axis. And we went all the way around once, and we came up some more, and we stopped here. And that's the terminal arm. So we talked about positive rotation, so 360 degrees, being all the way around to here. Notice if we made it all the way up here, it'd be 360. So what are we missing? We're missing 40 in here, so 320. This one says negative 120, so we have to go the opposite direction. So this is negative 90. That'll be negative 120. That's negative 180. Doesn't matter where you put it in here as long as it looks half decent. 480 degrees. All the way around is 360. Another 90 is 450. So 480 will be a little bit more over here, so we draw it in there. And we show that we went all the way around. The principal angle, that's a definition. I think I missed that part when we were doing it in class. So the principal angle is going to be the coterminal angle. That is the smallest positive angle between 0 and 360. And what do we mean by a coterminal angle? A coterminal angle is an angle that has the same terminal resting point. So this is 360 degrees, or 320 degrees. We could also get to the same point if we came this way, if we went negative 40 degrees. So 320 degrees is coterminal with negative 40 degrees. Which one do we take? Usually the principal angle, the one between 0 and 360 that's positive, So we're going to call that 320. Let's look at 120. Negative 120. Negative 120 is here. A coterminal angle for 120 is 360 minus 120. So 240. So 240 degrees will get me to the same place as negative 120. They're coterminal arms because they have the same terminal resting point. But which one do we take normally? Normally, we would, if we're giving an answer, we want the positive one. So we'd want the 240 here, not the negative 120. Take a look at this. 480 degrees. Well, that went all the way around and then some more. So a coterminal angle, instead of going all the way around and then some more, skip going all the way around, just do the some more. So it would be 480 without the 360 before it. So that would be 120. So 120 degrees here is the same as 480 degrees. It takes you to the same place. Which one would we prefer our answer to be? The 120, because it's the smallest and positive between 0 and 360. So there you go. Cast rule we talked about, related acute angles. So these are where your related acute triangles are. In quadrant 1, it comes here and it's up from the horizontal. In quadrant 2, it's here and that's your related acute angle. It comes up from the horizontal. In quadrant 3, it's here and it comes down from the horizontal. This is a related acute angle. And in quadrant 4, it's here and the related acute angle comes down from the horizontal. Now let's talk about these just for a minute. So let's say related acute angles are always measured from the horizontal. That's important. This is not a related acute angle. It would be measured from the vertical, and that's not right. This is not the related acute angle. It would be measured from this vertical, and that would be wrong. Okay, it's always measured from the horizontals. Now let's say I had an angle here, and let's say that my angle was theta. The related acute angle here, okay, is also theta. The related acute angle here is also theta. The related acute angle here is also theta. How do you come up with the rotational angle that gets you there? Well, if you look at this, that rotational angle to get you here is going to be 180 minus theta. The rotational angle to get you here will be 180 plus theta. Okay? So the rotational angle, if I know that this is my related acute angle, is going to be 180 minus theta to get that angle. To get this angle, I have to go 180 degrees plus the extra theta. And to get this angle, now remember, it's the one all the way around. To get that rotational angle, so that I have this related acute angle, it would be 360 minus the theta. Okay, because instead of going all the way up, you're just coming up and not traveling the related acute angle. So all of these blue angles are related acute angles. So theta are the related acute angles in each quadrant. Okay, there they are. The brown ones are the rotational angles to get there. Okay, starting from your initial arm, which of course is this way. Okay, I'm going to stop there just so that this video doesn't get too long, and we'll do the second part in the next video.